Welcome to the deep dive. Today, we're tackling AI agents, specifically looking at some recent insights from Anthropic. We're going to skip the really abstract theory and focus on, practical, real-world stuff you can understand quickly.
Absolutely. There's just this huge buzz around LM agents across, well, pretty much all industries right now. Everyone's trying to figure out what actually works.
And here's the really interesting bit. Anthropic, from their work with lots of teams, they found something kind of surprising. The most successful agent setups. They aren't these, massive, super complex systems.
No, exactly. They're finding that simple, clear, composable patterns are really delivering the goods.
That's a huge takeaway right there.
Right.
Don't jump to thinking you need some incredible, complicated machine to get value. Simpler might be better.
Right. And just so we're all on the same page here, agents can mean different things, can it? Some people might think, fully autonomous things running wild. Others think more like structured automations. What we're focusing on here, drawing from Anthropic, is where the LLM itself is dynamically directing things, deciding which tools to use, how to get there, not just following a script.
Okay, got it. So our mission for this deep dive is basically to give you a shortcut. How do you build effective AI agents? We'll dig into when using agents makes sense and, just as important, when it really doesn't. We'll break down the practical building blocks, the workflows you can actually use. Think of it as cutting through the hype.
Exactly. We want you to walk away with a clear idea of when and how to use this tech effectively without getting, bogged down in stuff you don't need.
Okay, so let's jump right in. The fundamental question.
Yeah.
When should you even think about using agents? And maybe more critically, when should you just not?
That's definitely the place to start. The core advice, really, is always aim for the simplest thing first. Only add complexity if you absolutely have to. Agentic systems, they often involve a trade-off, right? You might get better performance on the task, sure, but it could mean more latency takes longer and higher costs. You've really got to weigh that up. When is that trade-off actually worth it for what you're trying to do?
That's a great point. Don't grab the sledgehammer if a regular hammer will do the job.
Precisely. Think about it like workflows versus agents. If you've got tasks that are predictable, consistent, you know the steps, a well-defined workflow is probably more efficient. Agents really shine when you need that flexibility, when the LLM has to make decisions on the fly to handle a wider range of situations.
Okay, so if I'm just summarizing customer feedback, using a fixed template every time, workflow, that's simple.
Probably, yeah.
But if I need an AI to figure out a tricky tech support problem where the steps aren't always the same,
Yeah.
that's more agent territory.
Exactly. And, it's worth remembering that a lot of the time you can get really far just by optimizing single LLM calls. Things like good retrieval, giving the model the right info, or using solid in-context examples in your prompts. Often that's enough. You might not need a whole agent setup.
Okay, so simplicity first. Got it.
Sure.
But what about when we do need something more? There are frameworks out there. LangGraph, Bedrock's Thing, Rivet, Vellum. When do those come into play?
Yeah, those frameworks can definitely help you get started. They handle some of the plumbing, abstracting away how you talk to the LLM, define tools, chain calls. It can speed up that initial build.
So they're like starter kits for agents.
Kind of, yeah. They lower that first hurdle. But, and this is important, there are potential downsides. Because they add layers of abstraction, sometimes it gets harder to see what's really going on with the prompts and responses underneath. Debugging can get tricky.
Ah, okay. Like using a black box if it breaks inside, good luck figuring out why.
That's a decent analogy. And another thing is, sometimes these frameworks make it tempting to add complexity just because the option's there,
Right.
Even if a simpler approach might actually work better, it's still really important to understand the underlying code, even with a framework. Anthropic actually points out that making wrong assumptions about what's happening under the hood is a super common source of errors they see.
That's a really good warning. Understand the fundamentals, even if you're using tools to make things easier.
Absolutely. They even have sample implementations in their cookbook, which is worth checking out. But they also stress that often those simple composable patterns we mentioned, you can implement them with just a few lines of code. No need for a big framework sometimes.
Okay, simple patterns can be powerful. Let's get into what these building blocks and workflows actually look like. We'll start simple and build up. First, the augmented LLM. What's that about?
Right, the augmented LLM. It's basically your foundation model, your LLM, but boosted. Boosted with things like retrieval grabbing information, the ability to use tools, external tools, and memory so it can remember past interactions. And the key thing is current models can actively use these. They can decide, okay, I need to search now, or I should use this tool, or I need to remember that piece of info.
So it's not just passive access. The LLM is actually driving the use of these extra bits.
Exactly. And Anthropic really highlights two things here. Tailor these capabilities to your specific use case, make sure the tools and info are relevant, and provide a really easy, well-documented interface for the LLM to use them. They even have their own client implementation to help integrate with third-party tools, make that bit easier.
Makes sense. Got to make it dead simple for the LLM to know what it can do and how to do it. Okay, that's the base layer. What's the next step up in complexity?
Next up would be prompt chaining. Think of it like a sequence. One LLM call happens, its output becomes the input for the next LLM call, and so on. You can also slot in programmatic checks, they call them gates, between steps to make sure things are on track.
Ah, okay. So breaking a big task into smaller sequential steps for the LLM.
Precisely. The idea is, by making each individual LLM call simpler, you might trade a bit of time, the latency of doing multiple calls, but you often get higher accuracy overall. It's great when a task naturally breaks down into fixed subtasks.
Can you give an example or two? When would prompt chaining be a good fit?
Sure. Imagine generating some marketing copy, and then you need it translated into, say, French. You could have one LLM call generate the English copy, then you feed that output straight into a second call that specializes in translation.
Okay.
Or writing a long document. Maybe first the LLM generates an outline. Then you have a check, maybe programmatic, maybe another LLM call to see if the outline's good. Then you use the approved outline to write the full text.
Right. Breaking it down, focusing each step, makes perfect sense. What comes after prompt chaining?
After that, we have routing. This is about looking at an input, classifying it, and then sending it down a specific path to a specialized task based on that classification.
So like a sorting mechanism at the start.
Exactly. It's about separation of concerns. Different kinds of inputs might need totally different handling. Trying to make one process do everything can sometimes water down performance.
When would routing be particularly useful?
Well, complex tasks with distinct categories are a prime candidate. Think customer service again. You might get general questions, refund requests, tech support problems. Routing lets you send each type to a different downstream process, maybe different prompts, different tools, optimized for that specific kind of query.
That's clever. Avoids the one-size-fits-all problem.
Yeah. And another neat example Anthropic gives is optimizing for cost and speed. You could route the easy, common questions to a smaller, faster model like Claude 3.5 Haiku, then save the bigger, more capable, maybe more expensive models like Sonnet for the really tough or unusual questions.
That's a smart way to manage resources. Okay, routing. What's the next pattern?
Next is parallelization. This is where you have LLMs working on different things at the same time. Then you combine their outputs programmatically. There are two main flavors, sectioning and voting.
Okay, sectioning sounds like dividing the work up into independent chunks done in parallel.
Exactly. A good example is putting in guardrail safety checks. You could have one LLM instance processing the user's actual request, while another instance simultaneously screens that request for anything inappropriate. Anthropic notes this often works better than having one LLM try to do both things one after the other.
Right, like a dedicated safety officer working alongside the main processor. And voting, what's that?
Voting means you run the same task multiple times, maybe with slightly different prompts or settings, to get a variety of outputs. Then you use some kind of voting logic to pick the final result. It's good when you want higher confidence or want to catch a wider range of possibilities.
Can you give an example where voting shines?
Sure. Code review for security flaws. You could have several prompts, each looking for different types of vulnerabilities, analyze the code. If, say, 3 out of 5 flag something, you take a closer look. Or evaluating content for appropriateness. Multiple prompts, different angles on what inappropriate means. Only flag it if it hits a certain vote count.
So it's about getting multiple opinions, basically, to make the final output more reliable.
Exactly. Though they do add a little caution. For really complex tasks with lots of different angles, it might still be better to have separate focused LLM calls for each angle rather than trying to parallelize everything. Focus can still be key.
Makes sense. Okay, parallelization. What's the next level up in these workflows?
Now we're getting into orchestrator workers. Here you have a central LLM, the orchestrator. Its job is to look at a big task, break it down dynamically into smaller subtasks, and then hand those off to other worker LLMs. Then the orchestrator pulls the results back together from the workers.
So unlike parallelization, where the subtasks are kind of fixed beforehand, Here, the orchestrator figures out the subtasks on the fly based on the input.
That's the crucial difference. It gives you way more flexibility. It's really useful for those complex tasks where you just can't predict all the steps needed up front.
Can you give an example of where that dynamic delegation is really powerful?
Think about coding a new feature that needs changes in like 5 different files. The orchestrator LLM figures out which files what changes and then maybe assigns worker LLMs to actually edit each file,
Okay.
or a complex research task. The orchestrator decides which sources to check, then tells worker LLMs, you go analyze this paper, you summarize this article, and so on.
Wow. Okay. That sounds like it could handle some really complex stuff. What's the next pattern?
We're looking at evaluator optimizer. This is where one LLM generates a response, and then another LLM acts as an evaluator, giving feedback on that response. It happens in a loop.
So like a built-in critic and reviser.
Exactly. It's a system for self-improvement.
Hmm.
It works best when you have really clear criteria for what makes a good response, and when you can see that this iterative refinement actually makes the output better. It's kind of like the human writing process, right? Draft, get feedback, revise.
When would this evaluator optimizer loop be really beneficial?
Anthropic mentions literary translation. The first LLM might do a decent translation but miss some nuances. An evaluator LLM, maybe specialized in that literary style, provides feedback. The translator then refines it.
Ah, okay. For subtle tasks.
Right. Or complex search tasks again. The first search gets some results. The evaluator checks. Is this enough? Did we miss anything? It guides the process through multiple rounds of searching and analyzing.
It's like adding a layer of quality control right into the AI process. Okay, we've covered a lot of these workflows. Where do agents themselves, in the way Anthropic defines them, fit in? Are they just the most complex workflow?
They're sort of the culmination, yeah. Agents really build on all these capabilities. It's where the LLM shows strong understanding, reasoning, planning, reliable tool use, and even recovering from errors.
So they're more autonomous, more capable of independent action than the workflows.
That's the idea. An agent typically starts with a human command or maybe a chat. It figures out the goal, plans, and then mostly operates on its own. It uses tools, gets results back from the environment like tool outputs, code execution results, uses that feedback to see how it's doing, and adjusts. It might even pause and ask the human for guidance if it gets stuck.
Like giving the AI a mission and letting it figure out the steps, using its tools and learning as it goes.
Precisely. And what's interesting is, even though agents can tackle really sophisticated things, Anthropic says the core implementation can still be pretty simple. Often it's just an LLM using tools in a loop, guided by feedback. This really highlights again how crucial well-designed, well-documented tools are.
Right. The quality of the tools and how well the agent understands them is make or break. So when are agents the right call?
They're best for really open-ended problems, situations where you can't predict the exact steps needed, you can't hard-code a fixed path, you need to trust the LM's decision-making over multiple steps. Because they're autonomous, they're great for scaling tasks, especially in trusted environments.
But that autonomy sounds like it could have downsides too. Higher costs, errors.
Absolutely. More autonomy can mean more API calls, so higher costs. And if an error happens early on, it can compound through later steps. That's why Anthropic really pushes for extensive testing in safe sandbox environments and putting good guardrails in place. You need safety nets.
Empower the AI, but keep control. Makes sense. Can you give some examples of agents Anthropic has built?
Yeah, they mentioned a coding agent. It tackles tasks from the SWE benchmark stuff that often involves editing multiple files based on just a description. And they have a computer use reference implementation where Claude can actually use a computer interface to do various tasks. These show agents planning and executing complex multi-step actions.
Okay, so these patterns, augmented LLM, chaining, routing, parallelization, orchestrator, evaluator, and agents, they sound like really useful mental models. Are they strict rules, though?
Definitely not strict rules. Anthropic is clear. These are common patterns, kind of like design patterns in software. Developers should adapt them, combine them, customize them for whatever they're building. And the key, like always with LLMs, is measure performance, iterate, see what works. And they keep coming back to that core advice. Only add complexity if it clearly makes things better. Don't just make it complex for complexity's sake.
Start simple, measure, only add complexity if justified. Sounds like solid engineering advice.
Mm-hmm.
Okay, wrapping up this section on building agents, what are the key principles Anthropic emphasizes?
They kind of boil it down to 3 main things. 1, keep the agent's design simple, especially the planning parts. 2, focus on really clear communication between the agent and its tools. And 3, really put effort into crafting the agent-computer interface, the ACI. That means thorough tool documentation and testing.
That agent-computer interface point keeps coming up. Making it easy for the agent to use its tools seems critical.
Absolutely. They also say, look, frameworks can help you start, but don't be afraid to peel back those layers of abstraction for production systems. Use the basic building blocks. Following these principles, they argue, leads to agents that are powerful, yes, but also reliable, maintainable, and ultimately trusted.
That's a great summary. Now, Anthropic also included some appendices looking at where these agents are really showing value in the real world. Let's touch on those. First, customer support. Why is that such a hot area?
Yeah, customer support is interesting because it naturally mixes conversation, like chatbots we're used to, with needing to do things using tools. It makes it a really good fit for these more open-ended agents. Support chats often need external info, customer history, knowledge bases, and might need to trigger actions like processing or refund. Plus, you can usually measure success pretty clearly. Was the customer's issue resolved?
Right, and the fact that some pricing models are based on successful resolutions really shows the business confidence there.
Exactly. It proves the value. The other big area they highlight is software development. We've seen LLMs helping with code, but this is moving towards more autonomous problem solving.
Why does software development fit agents so well?
Well, a few reasons. Code solutions can often be checked automatically with tests. That gives the agent instant feedback to iterate on.
The feedback loop.
Right. The problem space, coding, is complex, but it's also pretty structured.
Right.
And you can objectively measure if the output works, right? Does the code compile? Does it pass tests? Does it fix the bug?
Anthropic even mentioned their agent solving real GitHub issues from SW Bench just based on the description. That's pretty amazing.
It really is. But they're also careful to point out, even with automated tests, human review is still vital. You need a person to check if the solution makes sense in the bigger picture, doesn't break something else, etc.
So, AI does the grunt work, humans provide oversight. Got it. Now, the second appendix was about prompt engineering your tools. This sounds super important, like the tools need as much attention as the main prompts.
Totally. Anthropic basically says tools are probably crucial for any real agentic system. They're how the agent interacts with the world, with APIs, with services. And their big point is how you define those tools, the descriptions, the parameters. That deserves just as much careful prompt engineering as the instructions you give the agent overall.
They use that example of editing a file, describing it as a diff versus rewrite the whole file.
Yeah.
Can make a huge difference to how the LLM handles it.
Exactly.
Oh.
Or structured output, getting an LLM to return code inside Markdown. Often easier than getting perfectly formatted JSON with all the right escaping. They give some good tips for tool formats. Give the model space to think in its output, keep the format close to natural text, avoid tricky formatting overhead like counting lines or complex string escaping.
It really does sound like designing a UI, but for an AI instead of a human.
That's the exact analogy they use. They talk about HCI, human-computer interaction, and say we need the same level of effort for ACI, agent-computer interaction.
So what are some practical tips for good ACI design?
They say, put yourself in the model's shoes. Is it obvious how to use this tool just from the description and parameters? Include examples, mention edge cases, specify input formats clearly, define the boundaries between tools, optimize the names and descriptions like writing a good doc string for code, and crucially, test tool usage like crazy. See where the model messes up and iterate on the tool definition.
Yeah, you have to see it in action to find the rough edges.
And they even mentioned poke-yoke, that error-proofing idea. Change how the tool works, its arguments, to make mistakes harder. Their example was switching to absolute file paths for their coding agent tool because relative paths were causing errors when the agent changed directories. They actually said they spent more time optimizing the tools than the main agent prompt for their SWE bench agent. That really tells you something.
Wow, it's not just the brain, it's the hands too. The tools matter just as much. Okay, this has been a fantastic deep dive into building effective AI agents, really leaning on Anthropic's practical experience.
Absolutely. And if there's one big takeaway, it's that success doesn't necessarily mean building the most complex thing you can imagine. Often it's those simpler, well-understood patterns that actually work best in practice.
Right. Start simple.
Yeah.
Focus on that clear communication, especially between the agent and its tools. Only add complexity if you can measure the benefit. And remember those key insights for when each specific workflow makes sense.
Exactly. So maybe think about the tasks you deal with or areas you're interested in. Where could some of these simpler agent patterns, or maybe even just better optimized single LLM calls, make a surprising difference? It's worth pondering those immediate practical ways you could apply some of this. What could you build or improve right now?